in the India who introduced the leverage of IT in businesses. LIC is one of the corporation in India along with some other companies. So LIC Computer holds data pertaining to almost 10 crore policies, and LIC went online on 1964. And let me give you a introduction. Like in 1964, there was no SOA architecture, there was no distributed architecture, there was nothing. So in 1964, when they went online, so they had to go with a traditional legacy architecture, that is monolithic architecture. So this monolithic architecture is just a simple idea that anyone can get. There is a central data reserve from which different systems are communicating, extracting data. Then in LIC, there are different systems such as internal users, reports, claims, agents, and then customer care, financial system. And there is a central data reserve, which is also known as monolithic policy system. This is a monolithic architecture. So they communicate with each other. All these systems and all these data reserves, they communicate with each other through some interfaces. So obviously, because to communicate we need some kind of interface, and these interface, mind it, these interface are tightly coupled. So we know what is tightly coupled. Tightly coupled means these the systems, they depend on each other to communicate. So these systems are tightly coupled. So also tightly coupled is a disadvantage. We will be talking about how they overcome this problem. So let's talk something more about this monolithic system. So initially, most insurance companies, not only LIC but most insurance companies, they use this architecture. They used to build applications with the intention of fulfilling the requirement. See, at those times, they do not think, the insurance companies, not just the insurance companies, any companies, they do not just think that we will be making a software for something that we will be using for now, and maybe we'll be developing it, or maybe we'll be changing it in future. So at that time, they were just concerned about the project in hand. So they want to they want to build services for the current project they had in their. So these systems basically target a specific department in the organization, because since they were not this architecture was no smart architecture, and those in those times systems were no smart systems. So at those times these systems they basically targeted a specific department in the organizations, and these systems are also self-contained, means they do not have idea about other systems in the organization. That's why we use the interface, because they think they are independent, but actually they were dependent, and through interfaces they communicate with other systems. So these interfaces, they were custom built interfaces, means nowadays interface is a work of minutes and hours or even days. But at those time there were specific companies that were set up to just to make these custom interfaces. So just think about how big the deal was about making an interface and then making a system communicate with each other. And those days this interface played a very vital role of changing the architecture in many companies, and not just LIC. So the support for these custom interfaces were expensive. Obviously, if we want to get a service from a company, means for interface, nowadays interface can even built by an individual developer also. But at those time there were specific companies, though they were providing custom built interfaces, and to get that access they have to spend a lot of money. So obviously they were facing with giving away a lot of money just to go online. So these were all the disadvantages, like tightly coupling, custom interface, high budgeting. So after that, after this monolithic system, they had to go one step above. And around 1970s, distributed architecture came to limelight. Distributed architecture was introduced, and then LIC, they inherited this sorry, not inherited, they adapted this architecture in their system. So what distributed architecture did, and distributed architecture means more than one system existing in an architecture. They maybe working in different environments, but that's why it's known as distributed architecture. And here what happened, here also same thing, that there are still there were still existence of this custom interfaces, but there were not that much implementation of these custom interfaces. The main service, the main core systems, that is like, okay, in 1970s, many systems were developed, such as the CRM. I will just go to here. Many systems were, due to the evolving in computer science field, due to the various inventions in this computer science field, and also due to the evolvement of business strategies, new software applications such as CRM, that is customer relationship management, and SCM, like supply chains management, these all things were been introduced. So an insurance company has to implement all this CRM and SCM also. So for these things they used EAI components. You can see many they mostly use EAI components. So EAI components, what they did, what they used to do, they also provided this interface, this interface kind of thing, but they did not, I mean, they provided the flexibility. They provided the flexibility among all the systems, so that they should work. Here, see, here more than one computer system participates, and hence we call them as a distributed architecture. So these applications interdependently worked to complete core processes. They work interdependently. And what were the disadvantages that then the disadvantage here was inflexible integration technology. Now what is interface integration technology? So let we consider an example, like there are two, like in Odisha there is a head LIC office who wants to integrate source data of Rourkela LIC and one from Cuttack LIC. So what at that time what they used to do, they was to get the source data, and then they used to send this data to a custom company, and those company then integrated this data. And so all these were done like in hand and not automatic. So integration was still a problem in a distribution system also. So to fix this, and also due to this integration problem, they had to face a high cost evaluation. So to fix this thing, they then finally jumped to SOA architecture, because in around late 1990s SOA architecture was introduced. And after some time after that, so LIC was all ready to adapt this SOA architecture. So SOA architecture, SOA architecture, what they did, they replaced this EAI, that is our enterprise application integration. So and this EAI is used to facilitate integration. So while using SOA architecture, what they use, they replace this EAI component with web services. Now all these systems can communicate with each other through web services, that is by using the SOAP requests. So these so now let's see. Now first let us understand what is this SOA architecture in a small brief. So SOA is a style of developing and integrating software. So it involves breaking an application down into common repeatable services that can be used by other applications. As we know, SOA provides us reliability and reusability in both external and internal matters in an organization. Also, it works independent of the applications and computing platforms on which the business and its partners rely. Means SOA gives us SOA is platform independent. And also using this approach, enterprises can assemble and reassemble these open standard based services to extend and improve integration among existing applications. So as till now we have seen, integration was a very basic problem in all this, maintaining the business. So SOA resolved that. SOA provided flexible integration, and through SOA, support calibration was enhanced. Also new capabilities were built, and these also drove many innovations around this field. So this is a reference architecture of how SOA was being used in LIC. So in this reference architecture, we can see there are three layers. So obviously in this layered structure, we can see at the last we see there is a our application data layer, and in middle there was services that is used to communicate, and then at the top layer there sits the service consumer. So service consumer means the services that is used by us. So what were the services? Now, these services includes hosted web applications, desktop-based products, and external applications. So, for example, in hosted web applications, we have this profile manager, policy system, claim processing system, then loss estimation, customer portal, and everything. In desktop-based products, we have like a claim system, a review system, a compliance manager system, and in external applications, we have like CRM, SPM, and any estimation technique and everything. So these service interface where then communicates with the services that sits in the middle. So these services are also of two types, that is core technical services and business services. So in core technical services we have services like a search service, which is obviously search service is used to search in a database, or a data access service, a user management service, exception handling. We know all about all these services. What is a notification service, error logging service? And in business services means the services which gives us some output related to the business field, like a billing, contract, or any estimate checking, loss evaluation, claim processing. These are the business services. So and these services were used on the last layer, that is our data layer, which are used to contain the data being used in the applications, like application data, and then authentication data, and error and app logging data, and all. So this is a reference architecture, which is a layered structure, which shows how SOA was been achieved by LIC. So lastly, we'll discuss some business benefits that we get from SOA, and this is completely generalized benefits. So obviously we
No,
get
no, you
lower
don't
IT.
have to tell this benefits. We have read it. You
Yes, sir.
just tell how do you plan to implement. What is your planning? Okay, how do you
Yes, sir.
plan to implement?
So the plan is in this
Yeah,
reference architecture. This reference architecture is the road plan to implement
that's
SOA.
the road
So
plan. But how do you want to implement? How you proceed step by step? Because you have done 2 lab classes. So in
yes,
lab
sir.
classes, how you have learned and how do you plan to implement? They are the basic fundamental thing. This is the architecture structure.
Yes, sir.
Then how you yourself, Siddharth, will proceed to get a SOA based outcome, SOA based software.
Yes, sir.
How?
So, till now, what I have read about and what I can do in SOA, in SOA suite, using SOA suite. So, till now, what I know from that, what I can do about to implement LIC or insurance company like figure. So, first of all, building the web services, building all the web services that will be required, like these claim estimation, or like claim processing, or profiling and all. So all these, first what I will do, first I will categorize these web services, first I will categorize this each and individual web services, and then I will make a containment like this core technical service. I will make one like parent service and all. And after that, through the SOAP request process, now we have read about SOAP request, and we have read about that HTML, that form will use, and then WSDL file will use that file to understand like which parameters we will be using to access the data from the database, and which and how the SOAP request will be how the flow of the SOAP request will be from one service to other, and how they will be invoking the services, and which all this thing I have planned till now. What I have read from SOA suite, the plan is like this, sir.
Okay, Nirmal wants to take help of your software. Okay,
Okay,
he
sir.
wants to make a policy. For example, he is of the age of 25, so he will make a policy for 30 years and
Yes,
he
sir.
will pay 10,000 rupees per year. Okay,
Yes, sir. Yes, sir.
he will pay 10,000 rupees per year. So 30 years means how much? 30 into 10,000, some
3
3 lakhs.
lakhs. 3
3
lakhs.
lakhs. So Nirmal will be paying 3 lakhs, and you have to tell him that after 30 years, there is a possibility that you will get back 3 lakhs plus interest at the rate of 7%. So something, some another X amount. So he will be
Yes, sir.
getting back. He will be getting back if at all he sincerely pays all the 30 years installment annually. 10,000 he pays. Okay,
Yes, sir. Yes,
so
sir.
that is that is the investment side. Another is insurance side. What is insurance? If a person faces any problem, so the policy is insured for 3 lakhs. The policy is insured for 3 lakhs. So if any person faces any problem, mostly the major difficult problem, that is the death part. If a person faces that type of problem, then LIC pays him whatever is the amount of deposit. LIC pays him the insured amount, that is 3 lakhs, 3 lakhs or 4 lakhs or whatever may be.
Yes, sir.
So that information you need to give to a customer, that this
Yes,
is
sir.
the policy we have, that if any problem comes, we will immediately pay you within 7 days after getting all the details. Then if at all the person continues for 30 years, for example, then after 30 years you will be getting back this much money. So this type of information the customer wants.
Yes, sir.
Okay. And the manager, you are a manager. So you have 10 crores of policies like this. So how systematically you will keep record of the policies? How systematically? 10 crores of policies you are having. So how systematically in a distributed architecture, from the manager point of view, how you can organize it so that you can cater to the needs of the different customers, right?
Yes,
So
sir.
think in that angle, both from the customer angle as
Yes,
well
sir.
as from the manager angle, both.
Yes, sir. Yes, sir.
How this architecture, whatever you are seeing, how that comes into the picture, and whatever the class coverage has been done in 2 lab classes, you ask Abhishek Bhaiya, sir, मैं क्या
Yes, sir.
करूं? How I will proceed?
Yes, sir.
You
Yes, sir.
learn
Definitely, sir.
slowly. Okay, okay,
Yes, sir.
okay.
Yes,
This is
sir.
the basic architecture. You have got the glimpse of the architecture. Now the implementation part. How you will implement using different XML or anything. Just go step by step, and from the both from the customer point of view as well as from the manager point of view. What is manager's requirement? What is the customer's requirement? Okay.
Yes, sir. Yes, sir.
Okay, you have started it. Again, we will call you after a month, how much you have proceeded. So in
Okay,
the
sir.
lab class, you always keep it in mind that how I will proceed in my assignment. Okay?
Yes, sir.
Okay.
Yes, sir.
Okay. Some
Thank you,
progress you
sir.
have done. Now you think of how you will implement. Go through some articles, some literature to proceed systematically.
Yes, sir. Yes,
Okay.
sir.
Both from
Okay, sir.
the customer point of view as well as from the manager point of view.
Yes,
Okay,
sir.
okay. Next,
Thank you, sir.
Sarma. Mahendra Kumar Sarma.
Hello, sir.
Yeah, come.
Sir, is I audible?
Yeah, very well, very well, very well.
Yeah.
It's a very
Sir,
difficult task given to Mahendra Sarma. Drone
sir,
part one has to understand. Yeah,
sir,
go ahead.
sir,
Yeah.
actually, sir, I have some problem. So, like, I have discussed with sir, will you permit me for like someone will share my slide if it is
Okay.
not okay, sir. Sir, actually, my laptop is not in a good condition. Sir, oh, thank you, Pratik. Okay,
Okay.
sir, it is visible.
Yeah. Go
Okay,
ahead.
okay. First of all, a very good evening to all, and today I'm here to present on the topic like drone management, and it is worthy if I said like it is maybe it's a luck or maybe it's what I said worthy because it's one of the like most demanding and innovative topic, and of course it is not not wrong if I said like it was a most patriotic topic for any of the countries. And I'm lucky that on the Christmas Eve, sir has given me opportunity to present myself on this topic. So let's proceed on that topic for the presentation. Pratik, next slide. Hello, Pratik. Okay, so this is some background like introduction. It is also known as, like in a technical terms, it is known as an unnamed aerial vehicle, or like commonly known as a drone. So it is an aircraft without a pilot. So like I don't think that so much background is needed. So you can skip this slide. I was just to maintain a decorum of this slide. I just joined this slide. So Pratik, next slide. Hello. So the flights of UAV may operate with a various degree of autonomy, either under remote control by the human operator or by the computers referred to the autopilots. Drone allow opening previously unavailable opportunities to see invisible and reach the unreachable, not only in the air but also in the ground and underwater. Next slide. There's some history about the, like how the journey of that drone, some like how the picture of drone came into the existence, and how, like how the people are thinking about there is a need for the drone. So basically there was a history, long history. I was just included in the slide, but there is no need. So first let's start, which is not the part of our discussion because we have to mainly emphasis on the architecture part. But before, when the people is starting about the drone in 1983, the first UAV was coming into the existence, and it was just a failure. It was like a balloon, and people thinking that we have to do something with a balloon and it will go in the aerial route and for find some pictures. So different, like time to time it was developed. But Pratik, next slide. Next slide. Next slide. This is also, so like one of the most like I want to discuss about that in 1973. This is important because this is the first slide when it was a game success. It was a first drone which is actually successful. Like Israel developed UAVs for surveillance. It was like in a, when Israel and other seven Muslim countries having a war, Israel has used these surveillance systems and drones for the destroying the two of their aerial routes and area for the, what I say, I was not finding the word. Israel using that in the fighting, that Israel using these drones, and after that there was a vast increase in the uh, development of the drone, and now the further processes. Let's skip these slides. Hello, Pratik. Now skip this slide. Hello, Pratik, skip that slide. Yeah. So as we all know that nowadays drones are used in almost all the industries, and modern drones are not only about the trailing aerial footage, and drones are gaining popularity across all kind of market. By the year, it was expected that by the end of the year 2022, we have expected to reach the $10,738 millions of business. Next slide. There are some, almost we can say that now drone technology are using in almost all the fields, but there I have included in my slides some of the fields like construction, surveying buildings, creating like maps, and building roads and railways, counting construction supplies. There are so many other applications of drones in the construction field, but I have included these only. So next slide. Pratik, next slide. Yeah, and if I said that previous one, this is important because now there's like, as for the Indian concern, like 70%, as we like as the data, we have more than between 60 to 70% of our population is dependent on the agriculture. So there like in the 90s, from 90s, it was the when drone came into the existence for the helping the agricultural field. like it was a monitoring plant livestock and monitoring water use and spraying crops. Drone has made very effective role in this agricultural field. And I have mentioned one thing, like it was very important, like in the very like last year, our prime minister has one vision to helping the farmers by the drone. He gave the idea that in a like we have a large vast land, so some portion of the India, like it was not a very heavy rainfall, like Rajasthan and all those things. So what happened, how can drone helpful for those reasons to cultivate the crops at those area? So they have suggested the team that we have a windmill there, and windmill is windmill is there, and if windmill has a certain we have created or we have developed certain systems to that windmill will absorb some from air moisture from that wind, and it will store. We have something storing device, and after that when it is stored that moisture, and it converted into the water, and then by using that drone system, we had spread that water into the plants. Like, so we are easily managed to cultivate certain types of plants like peas, mustards and grams, which need very less water. So it was very helpful in the field of like agriculture. There are so many other fields, like, please, next slide. Hello, Pratik, next slide. Yeah, one of the major, like in the last slide, like he's talking about the one of the my friend is talking about the insurance, like LIC. So insurance in insurance field also, drone has very large impact, like damage inspection, risk management, fraud monitoring. And nowadays people are like doing lots of frauds in the for earning more and more money. So at the very less time, drone will be there and monitor that is it correct, damage is actually done or not. So drone is also helpful in that areas also. Next slide. Yeah, disaster management. This is also another vital. And drones play the very vital role in this field also, because in the COVID situation also, like you have seen that case, some of the there are so many movies on that, like one first aid is needed, yeah, or either blood is needed, and there is a jam situation, or in the same the COVID situation, drone system has supplied a very vitally and very fastly to the one hospital to another hospital, or one place to another place, and by or we can like redirect, or we can get the information by the drone very easily in the case of disaster management. Uh, Above, like other slides, for the slide I have included one of the great example of the this disaster management, in how the disaster management drones are effective. So by the next slide I will discuss more about that. Next slide. Yeah, security, drones are normally, all the people are definitely known about that, how it is important for security, because mostly when we are talk about the drones, like the first picture came to in our mind that it is more effective for the to increase the security, to boost up the security, because like to monitoring the some public figures, or to ensuring the any public meetings, or state boundaries, or the national boundaries, as India is a very large land. So we are sharing the borders with the China, and of course for the Pakistan, Bangladesh. So it is very hard job for the like our soldiers to put up the restrictions to everyone, so or all monitoring everything at every time. So there was a drone, like we have used drone system on those topic, and by like in the news channels, we every day we are like seeing or listening this by the drones we have putting the eyes on the boundaries of this. So we will easily, by using drones, we will easily monitor those like areas where our boundaries are being safe. So next slide. Now this is like the part of our discussion. Now the drone software architecture. So like a drone software architecture includes several parts, but mainly what we have to be emphasis, like mainly it has a three module, like system software, user software, a cloud-based control platform. Now coming to a system software, it has a three component: embedded software or OS and web cloud interface. Now what is embedded software? Which operates as a CPU, like a uh, tracks drone element and partially analyze the data received from drone sensor. Like when I'm saying about the drone sensor, it includes many things like thermal cameras or like GPS systems or some other sensors. So, and a second one is the OS. So as we all know that about the OS, it works as an interface between hardware and software components, which allow user to operate firmware part. And third is the web and cloud interface, allow accessing the OS from remote drone system, streaming gathered data from embedded software to the cloud and mobile devices. Next slide. Picture. Like if we are go to the and or we are good, just put up the previous slide. One more thing is there. Previous slide. Yeah, like the first part I have is like system software and user software and cloud control based control form. So in the user software, what happens? Uh, it covers the front end and back end part of the web and mobile applications. They help user to plan and conduct flights as well as the display data from drone user. User software also include the interface for the communication with the cloud and the drone. And the third one is the very important as a cloud. Now the question is why we are using cloud, because now the drone is working without a cloud, like system software, user software. If we have developed any medium to synchronize between them, so there is no need for the cloud, but there is need for the cloud. So what is that? Like it is a used to data processing, storage, and analysis. It also enables the drone autonomous response action. But the cloud is important because when we comes to the complex things like complex mapping or something, when we are taking the complex 3D maps or like some complex picture, so cloud is important. At that time, by using only storage image is not it, because at that time moment of time we need a clarity, and for that lots of storage is required. So only by the storing device we cannot handle these things. So at that time a cloud is important. So next slide, please next slide. Yeah, so this is a global description of the like how the drones are working. So first of all, like here before we start, I was wish you to share that uh, like how they are. I have taken the one example, and now I'm trying to show you the working of that drone system with our UAV system, or you can say that UAV system by the one of the example. Now let's consider a case study of a tsunami that was came in the like I think 26 December 2004, I think, if I'm not wrong. So 24 December, I have taken that scenario, and our aim is to design an UAV system for identifying the alive victim location in the tsunami disaster. I hope it is clear. So now, if we see that in the picture, there is a live victim, and by using his UAV system, is a drone is taking the picture, and he will display or send the picture to the computer display like a server, and server will display by using the antenna. So like what it was explaining here, a UAV unmanned system can be designed to make a detection of the alive victim location after disaster happen. It consists of four components, namely UAV and base station, SAR. SAR terms as like a search and rescue team, like and the communication system. Now next slide. Next slide. Yeah, this is important. It is a working of a like a block diagram of a UV system. So as like as the diagram, we have one by one I've discussed what the role of each and every one and how it was working. The UAV is an autonomous aircraft that is a fixed wing. The aircraft is not controlled directly by the pilot. Instead, if it is controlled by using the navigator in the ground base station, that is on the base station. And the navigation command is sent by the navigator using wireless communication. The aircraft basically have three main parts. First has its physical body, Second is transmitter for the communication, and last one is SBC, single board computer. And how they are working, next slide. I have to next slide, Pratik. Hello, Pratik. Next slide. Hello. Yeah, this is a picture of SAR team. It as a component, I have decided to also include that how SAR team, like search and rescue team, is working. Hello. Hello, Pratik. Hello. I'm not able to visit. Hello. It is not clear.
I'll give him some time. He's actually changing, but I think his net is slow.
Yeah. Oh, sorry.
He might be using mobile phone.
Oh, sorry. Yeah. Now that the SAR team is okay. Now again you have changes. Put hold on hold. I think net connection is not good, either mine or you.
Just tell him slide number.
Presently I'm seeing back. Just go to the back slide. I am in the 18, but I have to just back one. Okay, yeah, now the 17 is okay. Now I'm able to see. That's okay.
Okay, on which slide you want?
Yeah,
Actually,
17
I was
17 is okay.
so I am on 17 from
Yeah, but
last 10 minutes.
no, actually what is Pratik,
Okay,
what is
okay,
happening
okay.
when you changing the slide net was frequently changing. That was I now.
Okay,
Now I'm seeing the slide number 1. Okay, 2. Okay.
I'm going to 17. Yeah, now it's 17.
Yeah. So it was like a base station. How the base station, it was the base station on the ground, how it was working. So as we have the UAV station, victim location, operator, different things, and how they are connecting to each other. There are mainly 3 components which are included: interface, antennas, and operators. The computers are used to process the decision of UAV navigation and display the conditions and location of the alive victims in a digital map. So location of alive victim is in a digital map and are obtained by the processing alive victim location obtained by the UAVs. And the second part is antennas. Antennas are used, definitely antennas are used to communicate with different parts from that UAV. By using UAV will send the signals to the antenna, and antenna will proceed it to the ground station. Then the operators, definitely the operators are the human who navigate UAV and give SAR, search and rescue team commands to make the action, what action have to be the further proceed and how we have to save them. Now the further planning has to be done. Next slide.
I am on 18.
Yeah, that's fine. SAR team. Now the yes, SAR team is strategy. So what is what happened with how they are after getting the signals, after finding or detecting the that where the victim is, after when SAR team get the information that there is the one victim who is alive. So what we have to now, what is the strategy of and how they are working in the SAR team. SAR team is like, first what happened before starting that step, one step ahead. First, it's also it is a responsibility of drone system to also find the safest place. Like once once the drone will send the picture that this place is not okay, and the victim or that man is there, and again the drone sent another picture which tells that this is a better place, nearest to him, nearest to he or she, just put it to that place. So for after completing these two images or by two messages, SAR team is completed by the GPS tracker, and which transmit the location to the base station, so base station can track the route of this SAR team. And base station combined SAR team location, like as we have see the arrows, two arrows are there. Like it is also the responsibility of the base station to combine that the route of the information and also the SAR location. So this way, like in this figure, we will see that the base station has also a responsibility that to combine the route information and also the victim location. So next. Like it is how the communication is done between this system. So communication between, there are several types of communication as we see in the figure, like in the diagram. There are several types of communication, like communication between victim and UAV, and communication between like SAR team and station, base station, communication between SAR team and victim, communication between like drones and victim. So like as clear, like in a figure we see that there is a communication between, first communication between UAV and victim. So it is definitely held by the thermal camera, or and that there is a wireless network established between the UAV station and the base station, UAV system and base system. And in the same similarly, like in a SAR team and a base station, when base station get the information about the victim, he definitely either by the any medium, like in the figure it was like a radio communication. So by the mission transmission, by using radio communication, it will, base station will inform to the SAR team to go, now the people, he is in the danger or he is not in the safe place, just you proceed to that place. So it was by using like radio communication, and these all are monitored using the GPS tracking system. So now that's I think that's the end of that my presentation. Thank you. Maybe like I'm uh, I'm not the right person to like answer your question, but yeah, of course, if you ask me any question, why your questions, it was like definitely enhance my knowledge, and sir is there definitely, so who can guide us, or like if he gives some valuable comments and valuable words, definitely it will enhance my knowledge and grab on this this project or this particular topic. So I request sir.
Okay. So you have to plan for this type of layered architecture what Siddharth has shown. Okay. What Siddharth Rautrai has shown. So that type of planned architecture for SWA-based development you have to think. Then you have to plan how you can start implementing. For example, in a central place like Gwalior, it has got 50 drones. Some of the drones will be used for the defense purpose, some of the drones will be used for the agriculture purpose, some of the drones will be used for the that insurance, the vehicle accident tracking purpose. So how the customers, the defense may be a customer, how the defense can take help of a drone from a central pool located at Gwalior, for example. So how the defense can take help of, how LIC can take help from the central pool of drones to identify the location of the accident and the severity of accident, And as you showed the agriculture, that water spraying, how a particular location in Rajasthan can take help from the central pool from Gwalior to irrigate the lands in Jodhpur. So how a customer can get the facility from a central pool and get his objective done? What is the distance it can cover from a base station? From a base station, I think there is some distance constraint. It cannot go long distance because its machine is small, and maybe energy, whatever the battery or fuel, that may not be that large to give it support for a longer distance coverage. So that is a constraint. So keeping that thing in mind, and for example, water spraying. So how big the container of water will be, how big the container of the pesticide will be, so that it won't be able to cover a longer area. So how it will frequently go back to the base station, refill those water or spray materials, then again come back. So they call it shortage or something like that. So you have to plan in implementation. You are a customer, both from the customer point of view, and you are a manager of 50 different types of drones. You are a manager, 50 or 500, whatever may be. As you showed towards 2022, there will be heavy demand of drones in every activity. So how you are a manager having 500 drones, how you will engage different drones for different purpose, and how a customer like Siddharth can use it for tracking the accident location. So you have to think from both the angles and start implementing. And as Siddhartha showed, the SWA is based on a layered architecture. So how you can think in that line? Okay? So think, start implementing. It is hard, I know. I know it is hard. It's very hard. It has a lot of constraint. It's not like insurance information system. It's not like that. It has a lot of constraint, the battery constraint, the distance it can cover. A particular category of drone can cover a particular distance and for a particular time span. So constraints will be there. So how you can start implementing? Think. I know it's a hard, very difficult information system we are planning to develop. It's a very difficult one. I know it. But a sincere effort will definitely help you start implementing to certain extent, to some extent. Not, but that will help you. A little bit of research paper, if you read, you can get some idea how far a drone can go and what are the constraints for it. So go through that and start implementing how you can proceed. So again, we'll call you back after a month. Okay? Okay. Okay. That's all. That's who is
Thank
the
you,
third
Pratik and
boy?
Subha.
Yeah. Who is the third boy? Who is the third boy whom I had told? Any? Mahendra, then Siddharth, then anybody third? I haven't told the third one. Okay, we'll close it today. I have got some work at 5:15, so I'll be closing it down. So Abhishek, आप attendance ले लो, ठीक है?
Yes, sir.
Okay, मैं थोड़ा close करता हूँ. मेरे को थोड़ा कुछ काम है department में. Okay.
Okay, sir.
Okay. Okay. We'll close it. We'll have the next class on Monday at 4:15 p.m. So till then, bye. So all start implementing. Ask Abhishek Bhaiya all your doubts. How to start implementing. Whether it is LIC, whether it is drone or any type of, whether it is for Andrila or whether it is for Somo, whether it is for Sony. ऋषभ सोनी, start implementing because time will fly away. हाथ से समय निकल जाएगा, टाइम निकल जाएगी प्लान करते करते. आप प्लान करके इम्प्लीमेंट कैसे, लेयर्ड आर्किटेक्चर हेल्प करती है, हाउ यू कैन स्टार्ट इम्प्लीमेंटिंग, थिंक, गो थ्रू सर्टेन लिटरेचर, हाउ टू प्रोसीड स्टेप वाइज. ओके, अभिषेक भैया.